All right, here we go. Unit 5, Lesson 12, Rational Exponents, Day 2. Again, that word rational, right, doesn't mean like we're used to it meaning in common language. It doesn't mean logical. It means ratio, like a fraction, m over n. And so what we learned in the last lesson was that if you have a fractional exponent, it is some kind of radical expression, right? This is a radical right here. Notice what I'm not calling it. I'm not calling it a square root because it's not always a square root. It's only a square root if it looks like this and has no root number there, which in reality is a hidden 2. But there's all kinds of radical expressions. There's cube roots and fourth roots to the 7/8 power. So we need to be really careful about calling that a square root. We're not going to do that. We're going to call it a radical, right? Or you could call it a root would be fine, but don't call it a square root. It's only a square root if it's 2. And what we learned is that when you have this fractional exponent, we learned that the denominator of that fraction, right? So this is the same as a to the m over n like that. The denominator is the root number. So that's what tells you, is it a square root, a cube root, a fourth root, a fifth root? That is what tells us that. And then the numerator is this exponent, which notice there are 2 distinct ways of writing this. You can either write the exponent on the inside or the outside of the expression. The reason for that is I want you to imagine, say we had the cube root of 5, and say we squared it. So right now it looks like the one on the right. Well, what does this mean? It means the cube root of 5 times the cube root of 5. And we learned that if these have the same radical, they're both cube roots, we could multiply these, and this would be the cube root of 5 times 5, or 25, the cube root of 5 squared. So notice this is the same as the original. Whether it's on the inside or the outside doesn't end up mattering there. If it's a bigger expression, you'll have to include some parentheses, but we'll see examples of that in a minute. Now that's a lot to remember. Here is the easiest way to remember it. Memorize these two. Memorize that to the 1/2 power means the square root. That is the by far most common one that comes up. Now the reason this is tricky though, and it usually we can't have that be the only one we memorize, is because both parts of this exponent are kind of invisible, right? This 2 we learned is the root number. So why is there not a 2 there? There's not a 2 there for the same reason that there's not a 1 on the exponent for an x. It's understood that if you don't write anything, it's the base case, right? We write x, we don't write 1x to the first, even though that's the exact same thing. So the base case of square root, there's typically nothing written there. So you want to have that one memorized just right off the bat. If I say, 16 to the 1/2, right? If I say 16 to the 1/2 power, that would be the square root of 16. That would be 4. You just want to have that burned into your brain. But in order to figure out more complicated ones, like if we had what is x to the 3/7? Well, then using the 1/2 square root 1 doesn't really help, as much because there's a hidden root number. So the one you also want to memorize, you want to memorize that to the 1/3 power means a cube root, because then you can back into, okay, the 3 is in the denominator, that goes there. So in this case, the 7 is the denominator, that would have to be the root number. This is the square root of, I did it, I said square root. This is the 7th root of x cubed. As you do more and more of these, this is going to happen naturally. I'm going to include this table here for you to reference today. You do want to start to get familiar with these square roots. You want to see 4 and think the square root is 2. Square root of 9 is 3. Square root of 16 is 4, and so on and so forth. You're going to become comfortable with all of these. The first few cube roots, you want to know your powers of 2, and you also want to know, that kind of spilled over onto the next page, you also want to know your powers of 3. What I mean by that is, if I give you a 32, right, you want to be on the lookout for, okay, 32, it might be expected that you see something like the 5th root of 32, And since 32 is 5 2's multiplied together, right? 2, 4, 8, 16, 32, the fifth root of 32 is 2. So you will see ones come up like that. All right, let's get some practice in. These are taken straight from the Desmos. So I'm just going to run through the 3 types of Desmos questions you might have. First would be working with real numbers. In the simplest case, it's just taking something like 15 and knowing that to the 1/3 power means the cube root of 15. Now, what I do have to look for here is I have to look for factors of 15. In this case, it's just 5 times 3. Neither of those are cube roots, so neither of those can be taken out of the radical to make it simpler. But if we had something like 24 to the 1/2, okay, 24 to the 1/2, I know that is the square root of 24, right? We've done this before in earlier lessons, and we have to think about, okay, 24 is 1 times 24, 2 times 12, and it's 4 times 6. Aha, there is a perfect square. So the square root of 24 is the same thing, right? And I actually think this way is easier to understand. It's the square root of 4 times the square root of 6. And so this would be 2 times the square root of 6. So I check again, 6. Well, 6, I've only got 2 times 3. Neither of those are perfect squares. 2 root 6 would be our final answer there. All right, last one here where the numerator is not 1. And so this is tricky here. If we have 64 to the 2/3, the first way I would write this is I would say, okay, denominator is the root number. This is the cube root of 64 squared. What the heck? The cube root of 64 squared. What's 64 squared? You could take this into your calculator and you could beep boop plug in 64 squared and take the cube root, and maybe that'll work, maybe it doesn't. This is harder to see unless you write it in the other form that I mentioned up top. The cube root of 64 squared. Well, the cube root of 64, is there anything that times itself and then times itself again is 64? Maybe I go back and look at my table. Yes, there is. 4 times 4 is 16, times 1 more would be 64. The cube root of 64 is 4. And so we go down here, the cube root of 64 is 4, and 4 squared is equal to 16. And so it says simplest radical form, but if there is no radical, that is the simplest form. So you'd go all the way to the finish line there. All right, let's do a couple more. What if we had variables and real number coefficients? If you have a parenthesis, then the radical applies to everything. And the way this works, for your variable terms, you use exponent rules. So remember our exponent rule, if we have x to the power of a to the power of b, that's going to be x to the a times b. That's going to be x to the a times b. And so what we have here is, let's first do the exponent rules. So I'm going to have 5/4 times negative 12. 5/4 times negative 12. And so, feel free to use your calculator on this one. But if we take negative 12, right? If we take negative 12 over 1 and we multiply by 5/4, that's going to be negative 60 over 4. That's going to be negative 15. So what I have here is x to the negative 15th power. Let's see about y. If I take 5/4 times negative 24, 24 is just twice 12. So I know this is going to be negative 30, but let's see it out. 5 times 5/4. That's going to be equal to negative 120 over 4. That is, in fact, negative 30. So we have x to the negative 15th, y to the negative 30th. Now here is what I would say is the really, really, really tricky part. You have to remember that these are just exponent rules. What we really have done, right, what we really have done here is taken the 4th root of x to the negative 12th to the 5th power. Whew! But we used exponent rules to simplify that. We learned our exponent rules to simplify that. But we don't have exponent rules when it comes to this 16. We just need to write the 4th root. Let me write that a little differently. The 4th root is the denominator of 16 to the 5th power. Now, once again, this is actually a lot easier to figure out as the 4th root of 16 to the 5th power. because the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So we're going to have 2 to the 5th power, x to the negative 15th, y to the negative 30th. Well, 2 to the 5th power is 32. So the final answer here is 32x to the negative 15th, y to the negative 30th. Final answer there. Woo, that's a lot. Let's do one more, and then that'll be it for this video. So if that was really tricky to you, make sure you're following along with this last one. All right, if we have 81 to the negative 12th times y to the 20th. All right, this is in parenthesis. And so we're going to have three things happen. This is negative 3/4 is going to apply to all of these things at once. So let's do the first one. 81 to the negative 3/4. Well, that's going to be, if this is a negative here, this is really tricky. This is 1 over 81 to the 3/4. I'm just going to leave it like that for right now. Just do one thing at a time. Negative exponent means 1 over the positive version times x to the negative 12th to the negative 3/4. So yeah, I like this actually. Let's just do the distribution first to show you what's actually happening here. Times y to the 20th to the negative 3/4. So all I've done is kind of rewrite that, showing that the exponent applies to everything. All right, well, 1 over 81 to the 3/4 says 1 over the cube root of 80. Oop, I did it. The fourth root, denominator is the root number. See, it's easy to get backwards. You got to check yourself. The fourth root of 81 cubed. I wrote it like this because I have a good feeling that that's going to actually be something that I can figure out. Times power to power. These multiply. So negative 12 times negative 3/4. Well, 3/4 of 12 is 9. 3, 6, 9, 12. So this is going to be x, negative times a negative, is a positive, right? Positive 9. So times x to the 9th, right? Because negative 12 over 1 times negative 3 over 4 is positive 36 over 4 is equal to 9. Then we're going to have for the y, we're going to have 20 over 1 times negative 3 over 4. This is going to be negative 60 over 4. This is going to be negative 15. So times y to the negative 15th. All right. The fourth root of 81 is 3, because 3 times 3 times 3 times 3 is 81. So we're going to have 1 over 3 cubed, right? Because I didn't deal with that 3 yet, times x to the 9th times y to the negative 15th. So 3 cubed, 3 times 3 is 9, times another one is, this is going to be 1 over, I'm going to leave some room here, 27, x to the 9th on top, y to the positive 15th on bottom. So written fully cleanly out, x to the 9th over 27y to the 15th. Final answer there. That is a doozy. That is a doozy. That is a lot there. Make sure to study this, to ask questions on the group meet, to read through the Desmos examples to see this written in a different way. I lied. There's one other super small thing, but it's just, I want to make sure we really cover this. Inside versus outside the radical. Just be careful. This literally is just 81 times the fourth root of x. So just be careful. If that exponent if there isn't a parenthesis here, it doesn't apply to the coefficient. Versus in this case, it would. The square root of 9 is 3, and power to power, x squared to the 1/2, this is just going to be 3x, right? Because this is basically asking, what's the square root of 9x squared? What times itself is 9x squared? 3x. Right, so just be careful inside versus outside the radical. This is a lot. Reference this while you're working on these today. Message me if you get stuck. And yeah, this is probably our last assignment of the quarter. So go back, check and see how you're doing with your Delta Math. Make sure you did the 2 edia.app assignments. And that's going to be probably it for this quarter. So nice work.